Hey people, this is me Code Sensei and welcome to my YouTube channel. My channel is about solving programming problems and explaining the solutions in such a way that you can understand how the solution is being constructed. So the problem that we are going to see today is the binomial coefficient problem, which is going to be solved using the dynamic programming approach. So let us go into the problem. So the problem statement goes like this. Write a function that takes two parameters n and k and return the value of binomial coefficient c of n comma k. For example, n is 4 and k is 2. You have to find 4k2 or 4c2, which will be the output is 10. So before telling you how we got this answer, we can first see what binomial coefficient means. NCR. In other words, it's the binomial coefficient. So, NCR means if you are given n number of items and you have to choose r number of items from it, then NCR gives the total number of ways possible. For example, if there are 10 students in a class and you need to pick 4 of them, the number of ways you can pick the 4 students is 10C4. So I hope you get what NCR is, and now we are going to see how to calculate an NCR. So we all might have studied in our school or college the formula for NCR, which is n factorial by r factorial into n minus r factorial. But what's wrong with this formula? Even though the final answer might be right, that is, we'll get the correct answer NCR, but we are going to go through calculations for n factorial and r factorial, right? Which might be much bigger than the answer itself. So there might be integer overflow, which means that n factorial may not be in the range of integer. So we are going to try to avoid this problem, and so we can think how can we reconstruct the formula or solution. So let us try to get a recursive solution here. Imagine the example of picking 4 from 10 boys. So for each boy in the group, okay, for each boy in the group, we can either pick him or not pick him. Let's assume that we pick the first boy. Now we have to okay, the number of remaining boys are 9, right? So we need to pick another 3 boys from the remaining 9. Or the other option is that we don't pick the first boy. Then we may have to pick 4 boys from the remaining 9, right? So the number of ways we can pick 4 boys from 10 boys is equal to number of ways we can pick 3 from 9 boys, and uh, adding to it the number of ways we can pick 4 from 9 boys. So this is the formula that we got for picking 4 from 10 boys. So now let's take 9. Let's take the problem of picking 3 boys from 9 boys. So we can either pick the second boy or leave him, right? That is, this is the second boy because we have excluded the first boy. So if he is picked, we will need to pick another 8 boys, and another 2 boys from the remaining 8. And if he isn't picked, we need to pick 3 boys from 8, right? If he is not picked, we will have to pick 3 boys from this 8, from these 8 boys. So to pick 3 boys from 9, the number of ways is picking uh, 2 boys from 8 added to picking 3 boys from 8. So, from this formula and the formula that we got now, are you able to find some pattern here? We have found a recursive solution to this problem. If you look closely here, n is 10 and r is 4. What is 9? N minus 1. That is 10 minus 1. Again, so this is n minus 1 and 3 is 1 less than r, right? And here 4 is equal to r. And similarly, here n is 9, n minus 1 is 8. Here n minus 1 is 8. And r is 3, r minus 1 is 2 and r is 3. So we have found the recursive solution to the problem, that is ncr equal to n minus 1 cr minus 1 plus n minus 1 cr. So this is the recursive solution that we have got. But when should this when will this recursion end? That is, every all recursive solutions must have a base case, right? So what is the base case here? Okay, imagine we need to pick no boys out of 10. How many combinations are present there? Only one, because we misleave all the boys. And imagine we need to pick 10 boys out of 10. How many combinations are present there? Only one, because we must pick all the boys, right? So the base cases of our problem are these. When the number of boys to be picked is 0, the answer is 1. And when the number of boys to be picked is equal to the total number of boys, that is r is equal to n, the answer is 1. So let us try to summarize all the findings and convert it into an algorithm. So this is the algorithm that we have followed till now. The base cases are when r is 0, the answer is 1. When r is n, the answer is 1. Else, the answer is the recursive part, that is n minus 1 cr minus 1 plus n minus 1 cr, right? So, okay, everything seems to be right here, but what's wrong with this? Can you find anything wrong with this, or do you think in some way can we do better than this? Okay, so let's take the example of 4C2. So this is the recursive tree that's going to have 4C2 is the sum of 3C2 and 3C1. And similarly, 3C2 is the sum of 2C2 and 2C1. And similarly, 3C1 is the sum of 2C1 and 2C0. And this is also the same. So, can you see here, there are some cases that are repeating. For example, 2C1 is repeated here and here, right? And so there are duplicate cases in our recursion tree. So these duplicate cases mean that we are recomputing things again and again, which is taking up that is, we are computing the same thing again and again, which is going to increase the time that our program is going to run. So these duplicate computations make the algorithm much slower. And how can we improve this? The solution is to apply the concept of memoization. To avoid duplicate computations, we can make use of a two-dimensional array to store the computed values for future reference. This is not computer, I'm sorry, it's computed values for future reference. This is known as memoization. that is storing the results of the computation for future reference. So, our two-dimensional array size is n plus 1 by n plus 1, where in this example the value of n is 4. Okay, the value of n is 4 here. So first, for finding 4c2, we have to find the value of 3c2 and 3c1, and then we are going to add both of them, right? Okay, to find 3c2, we need to know the answer of 2c2 and 2c1 and add them, right? So we know our base case, right? Here in 2c2, n and r is both the same. So for 2c2, the answer is going to be 1. Okay, coming back. After 2c2, we have to find the value of 2c1, right? 2c1 is nothing but the sum of 1c1 and 1c0. What's the value of 1c1? Here, n is equal to r, 1 is equal to 1. So, the value of 1c1 is going to be 1. So, we have found 2c2, 1c1. Then to find 2c1, we have to find the value of 1c0. Here, the number of items to be picked is 0, that is r equals 0. So, the value of 1c0 is 1, right? So, we have found the value of 2c2, 1c1 and 1c0. To find the value of 2c1, you must add 1c1 and 1c0. From the table, you can see that the value of 1c1 is 1 and the value of 1c0 is 1. So, adding them will give the value for 2c1. So, 1 plus 1, the value will be 2. So, we have found 2c2, 1c1, 1c0 and 2c1. Now, to find the value of 2c2, we have to add the values of 2c2 and 2c1. So, first we can go into the table and look for the value of 2c2. The value is 1. And we can go into the table to find the value of 2c1. The value of 2c1 is 2. So, the value of 3c2 is going to be 2 plus 1, which is going to be 3, right? So 3c2 is going to be 3. So we have found the value for 3c2. Now we have to find the value for 3c1. For finding the value of 3c1, first we need to find the value of 2c1, right? So we'll go and look into the table. Is 2c1 there in the table? Yes. The value of 2c1 is 2. And then we are going to look into the table for the value of 2c0. It's not there in the table. So we are going to compute its value. Here you can see that the value of r is 0, which is a base case. So 2c0 is going to give us the value of 1. So to find the value of 3c1, we are going to add the values of 2c1 and 2c0. The value of 2c1 from the table is 2. The value of 2c0 from the table is 1. So the value of 3c1 is going to be 2 plus 1, which is 3. So the value of 3c1 is 3. So now finally we are going to find the value of 4c2, which is the sum of 3c2 and 3c1. So what will be the value for 3c2 plus 3c1? We can first look into the table for the value of 3c2. The value is 3 for 3c2, and similarly the value is 3 for 3c1. So adding them up will give us the value of 6, which we will store in the place of 4c2. So we have found the value for 4c2, which is, and this is the answer for our problem. By using the concept of minimization, we are storing values, which has saved us from doing some computations again and again. This is called the top-down approach. But they say that pure dynamic programming solutions must not be recursive, but they must be iterative. That is, we should adopt a bottom-up approach. That is, we will go from these cases and then we will construct solution for the other cases. Let's see how it can be done. The bottom-up approach. Pure dynamic programming solutions are always not recursive. We know that we cannot pick 6 objects from a set of 5 objects. So we will be finding the value of IC0 to ICi in each row of our matrix, where I varies from 0 to n. For example, it just means that for 0 items, you can pick a number of items that is more than 0. That is 0 C1 is not possible, right? And similarly, for when you have only one item, you can pick items that is more than one. That is one C2 or one C3. They are not possible there. So it just means that for we cannot be able to pick n plus one items from n items. Right? So for each value of I, where I will range from 0 to n, we are just going to find till ICI and not greater than ICI. I mean, R value must not be greater than I. Okay. So this is how we are going to construct the matrix now. So this is going to be the algorithm for the bottom-up approach. Here, we have taken out all the recursive solution and we have replaced them with two loops, right? So, in the first loop, the value of I is going to go from 0 to n. That's because we are going to go to every row from 0 to n. Right? And then for each column, we just have to go till its value of row. That's for 0th row, we will go only to the 0th column. For first row, we will go only to the first column. For second row, we are going to go only to the second, and for the third, we will go to third, and fourth, we will go to fourth. Right? So for that, the value of j is going to go till ith value. Okay. So now, if this is nothing but the base cases, if the number of items to be picked is 0, or the total number of items equals the number of items to be picked, the value of I comma j will be 1. Okay, I think it's clear to all of you now, and else it's going to be the same solution that we thought before. If you have to pick one two comma one, that is n equal to 2 and r equal to 1, you have to pick one item from two items. You can either go up there to find uh, the number of ways we can pick one item from one item and add it with the number of ways we can pick one item from we can pick 0 items from one item. Okay, so this is nothing but we are just changing the recursive one to look up from the table. Yes, just that same statement there. So let us try to do it. So let's first the value of I is 0 and the value of j is 1. Right? So now, I'm sorry, the value of j is 0. For 0 comma 0, what will be the value? Here j is 0, right? So automatically the value of it will be 1. Then now the value of j becomes 2, and then the second loop will exit. Now the value of I will become 1 and the value of j will become 0. Since the value of j is 0, 1 comma 0 will be 1. And so now the value of I is 1 and j will be incremented to 1. Here we can see that I is equal to j. So the value of 1 comma 1 will also be 1. Now I is 1 and j is 2. But since j is greater than I, the second loop will exit. Now the value of I will be incremented to 2 and the value of j will be 0. Since the value of j is 0, the value of 2 comma 0 will be 1. Then the value of j will be incremented by 1. So to find the value of 2 comma 1, we will just go into the table and look for 1 comma 1 and 1 comma 0, and we will just add them up. So 1 plus 1 will be 2. So the value of 2 comma 1 will be 2. And similarly for 2 comma 2 is going to be 1 because it's nothing but the base case. Then the value of j will become 3 and it's loop again, and the value of I will be incremented to 3 and the value of j will be 0, which is nothing but the base case. So the value of 3 comma 0 will be 1. And then the value of j will be incremented to 1. So what is the value for 3 comma 1? It will be nothing but the sum of 2 comma 1 and 2 comma 0, right? So 2 plus 1 will give us 3. And then we are going to find the value of 3 comma 2. It's going to be the sum of 2 comma 1 and 2 comma 2. It's going to be 2 plus 1, which is 3 again. And then we are going to find the value for 3 comma 3. What is going to be the value for 3 comma 3? We know that it is the base case because n is equal to r. That's sorry, in these terms it's j equals I. So the value here should be 1. And then when the value of j becomes 4, it will exit the loop, and now the value of I will be incremented to 4. The value of j will be initially 0. So since j is 0, the value of 4 comma 0 will be 1. So now the value of j was 0, now it will be incremented to 1. So now we are going to find the value of 4 comma 1. The value of 4 comma 1 is going to be nothing but the sum of 3 comma 1 and 3 comma 0, right? Which will in turn be 4. Now the value of j will be incremented to 2. So the value of 4 comma 2 is going to be nothing but the value of 3 comma 1 and the sum of 3 comma 1 and 3 comma 2, which will in turn give us the value 6. And then the value of r, that is the value of j, will be incremented to 3. So it is going to give us the value of 3 plus 1, which will be 4. It will be 4. And then finally, for the value 4 comma 4, if nothing but the base case, so the value will be 1. And thus we have completed our table, and we have to return the value of n comma r as the result. The value of n comma r here is nothing but the value of 6. So 6 is our answer. If you see the table that we constructed now and look closely, it is nothing but the Pascal's triangle. Okay, so this table is nothing but the Pascal's triangle. So I hope you all like the solution, but there is another thing with this. When you see for calculate when you go bottom up and calculating the value for 4, you need just the values of its previous row, right? We don't need the value for the twos. I mean, when n equals 2 and n equals 1, you don't need it when you are calculating just for 4. So what you can do is you can make your program even more efficient by using a matrix of only two rows and n columns. In that way, once we, for example, when the value of after we found out the value of 1, we can just shift these elements here and erase them here. So this will come here, and what I am saying is we can just swap the elements and use the same space again and again, so that our program will be more memory efficient. So thank you for watching the video, guys. If you like my content, don't forget to subscribe to the channel and click the bell icon for immediate notifications. This channel is going to be purely for coding and programming the questions. So if you are interested in this, don't forget to subscribe to the channel. And if you want me to try out some problems and post videos about them, you can mention them in the comments below. Thank you and have a nice day.